My name is Tepankati, and I will be taking you through today's session. Like I said, it's on functions and inverses. Today's session is especially paced for you, our incredible rising stars. Keep showing up and doing the work. You are definitely on your way to greatness. Whether you're joining us on Zoom or TikTok, you are in the right space to ask questions. Please take your time and get the support that we need. Before we start, right, remember to like the session, subscribe or follow the learning space, and share it with your classmates. Remember that, remind them that the session has just begun, and sharing is caring, guys. Why? Because success is better when we all win. Okay. Now let's break down functions and inverses. Make sure that you do have your calculator, you do have paper and pen, because you will be doing a lot of writing. And I will ask you some questions to do on your side as well, so that we can share the answers. Okay. Now, if you have any questions, you're more than welcome to use the Q&A, right? Remember, let's establish some ground rules. Don't just say, sir, repeat. You need to be very specific with what you'd like me to repeat. If you say repeat, it doesn't really tell me much. I don't know where I lost you. You must tell me exactly where you are lost. Okay? And please ask as many questions as you want. If you're lost, we don't mind explaining this over and over again until you get it. But we need you to just communicate. All right. Perfect. Let's dive right into it. Just bear with me for a second. You will be able to see the screen that I'm sharing, and then we are going to get started. Okay, you guys should be able to see my screen. So what we want to cover in today's session are the following: functions and relations, parameters of functions, inverse functions, and analysis of functions, right? The most important ones that they will test you on in this grade are going to be inverse functions and analysis of functions. Okay? Now, let's dive right into it. So let's discuss functions and relations. Okay. Now, they are all relations. Firstly, they are all relations, but they are not all functions. All right. Now let's start with this one on the left, a one-to-one relation, right? If you want to call it a relationship, that's perfectly fine. Okay. So what do we mean by one-to-one? What we're saying is, if we pick a random x value, we start with the x. For every x value that you pick, let me pick a random x value. So -5. If I go to -5 on the graph, I'm getting only one y value. All right. And that is a one-to-one. One x value gives me one y value. Now, let's look at the many to one. So many x values to one y relation. It's not a function, it's a relation, okay? So we're starting with a relation, but this particular one definitely is a function, but now I'm just explaining the concept of a relation, right? So let's say I pick a random x value. Maybe let me pick this one here. I'm gonna get that. So can you see that the y value is the same? So I'll say x1 there and x2. These x1s and x2s are different, but they give me what? They give me one y value. That's why we say many, because we had x1 and we also had x2, which are different. Both of these guys, they give me the same thing, which is the one y value. Okay. Now let's look at functions and relations. Okay, which one is a function, right? And which one isn't a function? right? Now, a one-to-many relation, remember I said that all of them are relations, right? But a one-to-many, so one X value giving you what? Giving you two Y values. So check, we picked 5, positive 5. If we pick positive 5, we're going to have what? The value on top and the Y value down there. So that is a one-to-many. All right. Now, is it a function? It is not a function. Why is it not a function? It's because we do the vertical line test for us to determine whether something is a function or not. So I'll just draw a vertical line anywhere on this relation that I have. There's my vertical line. Then I check. As I'm drawing my line, I'm crossing the graph there and there. So I'm crossing it once, twice. Because I am touching it twice, right? It is not a function. The vertical line test tells you. Okay. Now they can ask you questions. They can make it more interesting. They can say, how can you restrict the range of this graph such that you are now going to get a function? And we're going to deal with those kind of problems a little bit later. So please hang on. We will deal with some problems a little bit later. Okay. Now somebody's asking me to repeat the one-to-many. So all I was saying there is that one X value, right? Because we're saying one what? We start with the X. So one X value gives us many what? Many Y values. Let's check. How do we check? Vertical line test, crossing through that particular graph. Here's my vertical line, anywhere on the graph. Touching it there, that's once. Touching it again there, that's for the second time. But can you see that we have X is equal to 5? Now, if I ask you, what is the corresponding Y value when X is 5? You're going to give me two answers. You're going to say it's 2 or -2. So you see, one X value gives you two Y values, and that is a one-to-many relation. I'm hoping it's clear now. Okay, moving on. Now let's quickly just test if we understand what's happening here. Which one here, right, will be a function if we did the vertical line test? So for number 1, is this a function or not? Right. Vertical line test. If I draw my vertical line anywhere on the graph, passing through the graph, that passes the vertical line test. We must touch it only once. Okay. Number 2, I'm just going to go to the right. Vertical line test. Check. Once, twice. Not a function. Okay, now this one is said to be a piecewise function. You don't have to worry about it just yet. You'll deal with it next year in varsity, right? But this one is definitely going to be a function because you touch the graph once. So if I was to draw my line there, right? So what they will do is they will give you bounds where this side is not included and that side is included. So if you're touching it only once, then it passes the vertical line test. But don't worry about that for now. Okay? Now, the tan graph, is it a function or not? So number 4, definitely a function. Now, a semicircle, would it be a function or not? That would be a function. Now, a semicircle that exists in quadrants 2 and 3, function or not? So number 6. Number 6 is not a function because we are touching it twice. Number 7, is it a function or not? Number 7 is definitely going to be a function. We are touching it once. And then lastly, the heart. That is not going to be a function. Sorry to break your heart there. Cool. Now let's talk about the parabolas. Okay? Please make sure that you pay extra attention. I don't want you guys to be missing anything that I'm saying here. All right. So the standard form of a parabola is given by f of x is equal to ax squared plus bx plus c. We all know that one. That's the standard one. Okay. Now from the standard form, what we can do is we can get our turning point, right? How do we get the turning point of a parabola? We know that x is equal to what? Negative b over 2a. That's given, right? But unfortunately, it's not given way on the formula sheet. You have to remember this one. Okay? Now, for you to find the corresponding y value, you have to substitute this way in f of x. Because this gives you what? The x value of the turning point. So after getting it, maybe it was negative 5. You need to substitute it back in the original. So now you're going to find f of negative 5. Okay, now let's quickly discuss where this formula comes from. We spoke about the standard form. We said it's not f prime, but f of x is equal to ax squared plus bx plus c. Now, a turning point is either a maximum or a minimum. What do I mean by that? You either have a sad face graph or you have a happy faced graph. Okay, now can you see that this turning point is on top? Because it's on top, it has to be a maximum turning point. Now, this turning point is down there. Because it's in the bottom, it has to be what? A minimum turning point. Now you're going to do, some of you maybe have started with calculus. If you haven't covered it yet, don't worry, you are definitely going to do calculus, where we do derivatives. So derivatives is just f prime of x. We will say this is equal to what? 2ax plus b. That's when we differentiate. If you haven't covered it yet, please don't panic. Don't worry, you will cover it in class. And then from there, we know that at these points, the gradient is 0 because derivatives tell us about gradients. And f prime of x is that 0. So that's why we say 0 is equal to 2ax plus b. And then we solve for x, we are definitely going to get negative b over 2a. Okay. And that's where the x equals negative b over 2a is coming from. Okay. Now, we can also write it in the turning point form, right? Now, the turning point form comes when we complete the square, okay? But we're not going to complete the square now. That's for another lesson. The turning point formula is given here. F of x is equal to a into x minus p all squared plus q, okay? So what does this a tell us? It tells you the shape. Okay, Bupelo is saying that they are lost. Please don't worry. I was just showing you where this formula comes from. Like I said, it will be covered when you guys do calculus. You probably haven't done calculus yet. That's why you are a little bit lost, but you will cover calculus and it will make sense. And in any case, you are not asked to prove this, so don't worry too much about it. As long as you can follow from what I'm saying now, that's perfect. We're on the same page. So as I was saying there, that the A tells us whether we have a happy face or a sad face. So if our A is positive, that's the shape. If our A is negative, that's the shape, right? P and Q are what? Turning points. I hope we're all together there. Now you must be comfortable to use any of the two. All right, moving on. We will still do some questions a little bit later, so just bear with me to give you guys all the explanations that we need, and then we will tackle the questions, okay? All right, great question from Nomcebo. So, sir, the turning point form, the x value, does it change sign when writing it in point form? Absolutely, okay? So if we had a function f of x is equal to maybe -2 x plus 1 all squared, and then maybe, let me just say -3, why not? No, let me just say plus because it's a negative. The turning point of this one, okay, are going to be what? -1 and +3. Because we change this. So we're simply saying x plus 1 is equal to 0 and x is equal to -1. So that's what I did here. X minus p is equal to 0, x is equal to p. That's why my turning points are p and q. I'm hoping that makes sense to you guys there. Okay, now looking at this graph there before we move on, remember that this is also known as the what? The axis of symmetry. So if they ask you for the equation of the axis of symmetry for a parabola, all they're asking you is what? Find the x value of the turning point and write it as an equation. X is equal to. That's the axis of symmetry. Okay, somebody wanted to take a screenshot. You're more than welcome to do so quickly. Okay, perfect. Moving on. Now we're going to do some hyperbolas. So I'm going to give you guys the explanation of most of these graphs before we actually look at the problems. But I do have questions prepared for you guys. So just bear with me to give you an explanation, just so you have all the tools to tackle the questions that I'm going to give you. Okay, so the hyperbola standard form is what? Is f of x is equal to a all over x minus p and then plus a q. All right. Now, for hyperbolas, it's two pieces, but it's all one function, right? Two pieces, I mean, this is a piece and this is the other piece. That's the second piece, but we need both of them to have one graph. Okay. Now, it can exist in either quadrant 1 and 3, or what? Or 2 and 4. Those are the pairs. Okay, what do I mean? They check here. Look at the one that's provided on the screen. It's existing in quadrant number 2 and quadrant number 4. We can have this kind of a graph. Quadrant number 1 and quadrant number 3. Now, this is when A is what? Positive. This is when A is negative. You must remember that. A question that they like. I need you guys to pay extra attention now. They will say, please find the equation of the axis of symmetry that has a positive gradient. And then a lot of you don't know what to do there. But those are the easiest questions ever, because it's usually about 2 or 3 marks. I stand to be corrected. Now, here are the formulas that you need to follow. Make sure that you have these down. So if they're asking for the positive slope, so this one, this axis of symmetry, it's going to be number 1. If it has a negative gradient, it's simply going to be like that. Okay, let me just quickly repeat some of the things that I was saying. Your A value tells you which quadrant pairs you're looking at. If your A value is positive, right? If A is positive, This is where you're going to draw your graphs in quadrant number 1 and 3. That's when A is positive. But if your A is now negative, you're going to draw your graph, the pieces in quadrant number 2 and number 4. That's when A is negative. Right? So even if they give you maybe something that looks like this, f of x is equal to -1 over, let's just say, x minus p, and then we don't know anything. All we can tell at this very moment is that our graph is going to be where? In here and in there. Why? Because of the A value. The A value is negative, so it has to be in quadrants 2 and 4. The quadrants 2 and 4. I'm hoping the part of A makes sense, just like you guys requested there. So please do not make mistakes here. Okay, let's repeat the axis of symmetry, right? What do we mean by axis of symmetry? I think there was a question about the axis of symmetry. So the axis of symmetry is like a mirror. So think of it as a mirror that reflects the graph, okay, onto itself. So let's imagine this axis of symmetry here. So if I draw this line, this is now my mirror. Won't this piece be reflected on top of this one here? It will be because of that mirror. So the axis of symmetry is acting as a mirror. Okay. So we don't only have one axis of symmetry. We can have the one with a negative gradient as well. This one. So if I have this piece here is going to lie where? On top of this piece. Similar thing is going to happen here, where this part lies on top there. So this is also another mirror. That's the axis of symmetry. It's symmetrical. Okay. Now, if they ask you for the equation of the axis of symmetry with a positive gradient, what are you going to do? You're going to simply give them this formula, and then you're going to substitute what? Your P and Q values. I did prepare a question for us where they ask us for axes of symmetry. So please make sure that you copy this down so that you are able to do that question when we reach it, okay? And if they're asking for the one with the negative gradient, you're just going to give them number 2. Okay, now let's discuss P and Q, right? So P tells you about what? About translations. So we're moving the graph way left and right. So let me do this. It's going to look like I'm talking about reversible reactions. Yeah. So P tells us how many units left or right to move the graph. And then Q tells us what? How many units up and down to move the graph. And that's what P and Q stand for. All right. Now, very important, they will also ask you about what? Equations of asymptotes. Equations of asymptotes. Now, you have two asymptotes, remember. In your grade, they will give you a graph that has two asymptotes because you've done hyperbolas for a while now. So if our graph exists in quadrant number 1 like that and quadrant number 3, can you see that our graph does not touch the broken line, right? Our graph does not touch the broken line. Check here. This green will never touch this. It will never, ever touch it. And because it never touches, even this side, it never, ever touches that broken line. Even here, they will never, ever touch. Because they do not touch, we call those what? We call them asymptotes. I'm hoping that makes sense to you guys. Those are asymptotes. Now, the equations of those asymptotes, so let me give you guys a function. I'll just make up one. We're not going to do any calculations. This is just for me to further explain x and p. So f of x is equal to 1 over x minus 2 and then plus 3. Why not? Now, if they ask you for the equations of asymptotes for this particular function, what are we going to say? Y is equal to what? Positive 3. And then what is the y value of that asymptote? Sorry, the x value of the asymptote, we found the y1. X is going to be equal to 2. You guys are following. I'm happy about that. Right. Please do not mess up hyperbolas. They are quite easy. The one thing that gets you guys is the axis of symmetry, but now I've made it easy for you. Make sure that you've written this down. If you're taking a screenshot, please do so because you will need this. Perfect. Moving on. The exponential function. The exponential function standard form is f of x is equal to a times b to the power of x minus p plus q. Right. Remember that this function can also be what? Can be shifted left and right, up and down. So up and down is just the vertical shift. Left and right is the horizontal shift. Right. Now this function as well has what? Has an asymptote. There's a point where it doesn't touch. So if we start with this one, it will never touch the x-axis. So the x-axis in this case is the asymptote of this given function. What we can also do is we can move that function up. So let's say now it crosses at 2 and we had a function like this. Now we have an asymptote there. The graph will not exist here because it doesn't and it will never exist there. If this is 1 and that's 2, the Q value of this blue one is going to be what? Positive 1. The graph has been shifted up by 1 unit. I'm hoping it makes sense to everyone. Perfect. If it's making sense, remember to just give me a thumbs up. Okay, so the asymptote, right? Somebody's asking me to repeat the asymptote. So I'm saying that the first function is, let me maybe start it from here. Y is equal to b to the power of x. That function is just going to be a function that looks like that, right? It will never ever touch the x-axis. Because it's not touching the x-axis, the x-axis is the asymptote. So x-axis equals to asymptote. But what is the equation of the x-axis? Please don't say x equals to 0. It is y is equal to 0. That is the asymptote of this one. We can move this graph up. So now I'm going to say, let's add a 1 there. So now I have y is equal to b to the power of x plus 1 here. What does it mean? It means that my graph has now shifted where? This was the point 0 and 1. So if it's shifting up, it's now going to be passing through 0 and 2. Now, this is our graph. It's still the very same graph. It's just been shifted up. Because it has been shifted up, there's now a new asymptote that has been established there. It will never, ever touch this. And what is this value? So the value there is 1. Okay? Now, that is going to be what? Y is equal to positive 1. That is the value of that asymptote. Okay, here's a great question in the chat. Is it possible to have a graph that doesn't intersect the y-axis? For an exponential, for strictly an exponential, the one that they gives you will always touch the y-axis. Why does it touch the y-axis? Because it's increasing way to the left-hand side and to the right-hand side. Right? Even if I drew it like this, if I drew that one, can you see that it's going way to negative way, negative infinity on the x-axis? And then this side, it's coming down and it's also going to the right-hand side. To the right-hand side, that is what? That is positive infinity, right? That's why it always crosses there, because it exists for all those values, and 0 is one of those values. Okay, another question. So the formula of the asymptote is y is equal to b to the power of x. No. The asymptote is not y is equal to b to the power of x. The asymptote is whatever this is. Unless your question is, what is the asymptote of an equation or a function, which is y is equal to b to the power of x? All you're going to do is you're going to say plus 0. Now, what do you know? Q is equal to 0. Just to make your life easy. Okay, we are still going to talk about domain and range. So just bear with me for a second there. Now, we're starting with our exercises. I'm going to explain in depth what domain and range are and how I remember the two, because I used to confuse them. When they asked me for range, I used to give them domain until I had to figure something out. And I'm going to give you guys those tricks. Here's an exercise. Find the turning point, and the turning point form of what? Of f of x is equal to 2x squared minus 4x plus 6. Right? What is this? Is it a parabola, a hyperbola, or an exponential? The highest power is 2. This is a parabola, or you can say it's a quadratic. Okay? Thank you so much for the answers that are coming in. All right. Now, we want the turning point. Right? I want what? Both the x and y values of that turning point. Okay, somebody wants to take a screenshot. Let's just do that quickly. You can quickly take a screenshot because you're going to need it for other questions. So quickly take that screenshot and then we go back to the question. Okay, moving on. Here you have two options. I always say to my students that I want you guys to take the easiest way out. Right? If you want to complete the square, you can complete the square. But if you're not too comfortable with completing the square, and if your algebra is not the greatest, you might struggle a little bit there. So what are you going to do? X is equal to negative b over 2a. Then let's take the values. So that's going to be 4 on top. Negative 4 is just going to be positive 4. 2 into a, which is 2. And then x is how much? Positive 1. That's how we got it. Now, what do? We want to find f of 1. Right, this is not a 0, it's a 6. Excuse my handwriting. And then from here, calculator work. That gives you how much? That gives you a positive 4, which means this is going to have, so the turning point has the coordinate 1 and 4. Okay, everyone is with me there. Now we want the turning point form. What do we mean? We need in this form, y is equal to a into x minus p squared plus q. How do we do that? Right. If you guys already have an answer, you're more than welcome to post it in the chat. Okay, there's an answer from Gwena that I just want to note down. It's y is equal to 2 into x minus 1 all squared plus a 2. It looks like we're all getting the same answer. Right. What I'm going to do is I'm going to complete the square for this one. I always say that you have multiple options at your disposal. Always use the one that you think is the easiest for you. Please do not change methods now. As long as we're getting the same answer at the end of the day, that's a perfect method, okay? You must also remember to what? To show all your working out. Okay, somebody is asking, is it okay if you derive? Yes, you can derive to find the x value of the turning point. It's the same as using this formula. So some people have not done calculus yet. Maybe they don't know how to derive and what derivatives are. Okay, so this is a mistake here. Thank you so much for pointing it out. It is a 4. A 4. Why? Because we found the turning points to be 1 and 4. Let's complete the square. So for us to complete the square, the coefficient of x squared must be what? It must be 1. If the coefficient is anything greater than 1, we have to take it out as a common factor. So I'm going to say 2 into x squared minus 2x plus 3. Everyone is with me there, right? Now make sure that you are paying attention, because you do need to know how to complete the square. And it also helps you in analytical geometry, where you have to find equations of circles. Now we can complete the square. What does the rule say? The rule says take the coefficient of x. So let me just say minus 2x, right? You have to divide it by 2, and then you have to square it. There was a plus 3. We not say plus, it's a minus here. Just bear with me for a second. Let me just fix it. Okay, if you happen to see my silly mistakes, you're more than welcome to correct me. I'll try not to make any silly mistakes, but if I do, please do correct me. Now, remember something. Essentially, these two things actually cancel each other out because one is positive and the other one is negative. So we haven't really done anything to the equation. We've added 0. Adding 0 doesn't change the equation that you started with. Okay, so this is the equation that we started with, if you think about it. Now, what is it that we want to do? We want to write it this way. So the 2 is still outside. Now, this is a perfect square. So I will say this is what? X minus 1. But it must be squared. I'm hoping that's clear. So all I did is I took the square root of the first. Square root of x squared is just going to be x. Square root of the last. So 2 over 2 is just 1. Square root of 1 is just 1. And I looked at my sign. I need a negative. That's why I have a negative. Okay? Now 3 minus 1 gives you how much? gives you 2. So what we have is essentially this 2 into x minus 1 squared plus 4. And this is the equation in the form a into x minus p all squared plus q. The a value we got by taking out the 2 as a common factor. We took this out as a common factor. That's how we got the a value. Okay. Would it be possible if you could repeat putting the form? Okay. So all I did there is firstly, I took out I took out 2 as a common factor. If you take out 2 as a common factor, you're going to land here. Because remember the 2 multiplies in. Okay. Now this gives you how much? This gives you 2x squared minus 4x plus 6. Okay. Now afterwards, all I did is I completed the square. I think the problem with you guys is completing the square, which is algebra, right? There's a reason why we spend so much time on algebra at the beginning of the year, because we know it's very important for you to be able to do functions and other topics. You need to be able to solve for x, right? But don't despair. We do have lots and lots of videos that we've posted on our TikTok, our YouTube, that will help you with your algebra skills, including completing the square. We are just running out of time. And remember that the lessons are recorded. So please just revisit the recording after the session because we are running out of time. I've repeated it. So I won't be repeating it again, but the recording will be made available to you guys. We just have to move on and do other questions. Okay, now looking at this one here, find the equation of the upwards. There we go. Upwards sloping. What do we understand by upwards sloping? Upwards sloping. There, that's the upward slope. Because we read from left to right. So as we come from the left going to the right, we're actually going up. Yes, it's a positive gradient. Now they want the equation of the axis of symmetry. Remember I told you guys to take it down. I gave you the equations. Let's see if you really took it down. It's going to be an easy one for you guys to attempt. Try to find the equation of the axis of symmetry. Perfect. They gave you guys the equation in the chat, so you can use it if you didn't get a chance to take it down. The equation, people have x is equal to 3, some have y equals to 4, x equals to negative 3 plus 4, which means x is going to be 1. I'm just acknowledging the answers that are coming in on the chat. If you have a different answer, you're more than welcome to post it in the chat. Okay, 10 more seconds and then we look at this together. Okay, perfect. The equation is y equals to what? X minus p, then plus q. Now, isn't this x minus p? Take it like it is. So x minus what? Minus 3, and then what is q? So y is equal to x plus 1. And this is the equation of the axis of symmetry that is positive sloping. Remember, y is equal to a over x minus p plus q. So we just took the bottom as it is. That is our x minus p there. And I plugged it in there. I'm hoping it makes sense for everyone. Okay. Now, please don't get it wrong again. So why is the 3 not positive, right? So the 3 is not positive because when we find the axis of symmetry, so we're not solving for x, we are trying to find the axis of symmetry. So we're not trying to find the what? The asymptote. It will be positive 3 when we try to find the asymptote. So x is equal to positive 3. That's the asymptote. But this is x minus p from the equation. And we just plug it in like it is there. We do not change anything. Okay, now quickly moving on. Now let's look at analysis of functions. We do have just over an hour left and there's still a lot to do. We need to give you guys analysis of functions, domain, and range. But remember, the recording will be made available to you guys. There's still a lot that we need to do. So we just need to be careful of time there. So excuse me if I'm being a little bit fast on some of them. If we have time at the end of the lesson, I'll definitely come back and explain some of these concepts. I'm not dismissing your guys' questions, but I'll come back to them at the end if there is enough time. Okay, now analysis of functions, right? Now we're talking about the distance between two functions, okay? The statement there says we can find the equation for the vertical distance, in brackets height, between two curves by subtracting their functions together. All right, for example, h of x is equal to f of x minus g of x. We can also find the horizontal, so the horizontal distance between points by taking their x value differences. And that will just be x2 minus x1. Okay. What we're going to do then is we're going to try and find what? The length, the maximum length of what? Of AB. Now, AB is a vertical line, so we know that it's parallel to what? To the y-axis. So it means that A is directly above B. We want that distance. Okay? Now, that distance, AB, is going to be found by saying what? By saying the top graph minus the bottom graph. Okay, I see Karabo has raised their hand. I'm going to ask my colleague there to help you unmute yourself so that you can ask your question, Karabo. Let me see if I can help. Okay, Karabo, you're more than welcome to unmute yourself and ask your question.
Sir, it was a mistake.
Okay, all right, no problem. Moving on. Okay, so I was saying that the distance of AB can be found by saying what? The top graph minus the bottom graph. Okay? Now, in this case, what is the top graph? The top graph is going to be what? It's going to be f of x, because if you are anywhere here and you look up, you're going to see f of x. And if you look down, you're going to see g of x. So the top graph is f of x. I'll say f of x minus what? Minus g of x. That gives us what? AB. Now, don't we know what f of x is? We do know what f of x is. Minus x squared plus 6x plus 12. It's given there. I'm just taking it like it is there. Then minus. Now, this is where you need to be very careful. You have to put it in brackets. So maybe let's always do this. Let's put that in brackets. Let's do that. So that you don't make that mistake, because this negative needs to affect everything inside the bracket. So g of x is how much? It's just 2 of x. It's just 2x plus 1. Beg your pardon there. X squared plus 6x plus 12 minus 2x minus 1. This is what? Minus x squared. And then plus 4x. If I am making a mistake, you're more than welcome to correct me, but I think we are still fine. 12 minus 1 is just going to be 11. Okay. Now this gives us the equation of what? Of AB. Not the length, the equation of AB. What are we looking for? The maximum length of AB. And how do we do that? You have two options. You either differentiate or you what? Or you complete the square. I'm hoping it makes sense because what you're looking for there is what? The y value of that turning point. So you either complete the square or you what? You differentiate. Now let's see. If I differentiated this, I'm going to have what? Negative 2x plus 4. Right? If you haven't done calculus yet, do not worry. Try to complete the square. Right? What did we say? We said maximum, so this is equal to 0. Then x is equal to how much? X is equal to 2. And then we're going to substitute it where? In AB. So you have negative 2 squared plus 4 into 2 plus 11. And then from there, it's just going to be calculator work. And that gives you 15 units. Okay, now Ratabile has a question. So if I equate them, will I get the same answer? Absolutely not. So equating them is something that we're going to deal with now. That's when you are trying to find where they touch each other. That's where, when you equate, that's when you're trying to find these 2 points. That's when equating the two comes together. You got the same answer, Tabile, but the concept is not the same. So what you did is you simply said that the top graph is equal to the bottom graph. And then when you took it to the other side, it's equal to 0, but it's not equal to 0. It's equal to what? It's equal to AB. That's why I'm saying you must be very careful. You must be very careful there. You equate them when you try to find the point or the intersection point rather. Okay. Let's quickly look at completing the square. Okay, actually, let me just go back there. Okay. So the equation is negative x squared plus 4x plus 11. For us to complete the square, what's the first thing? Our coefficient of x squared must be 1, not negative 1, it must be 1. So I'm going to take out a negative 1 as a common factor. X squared minus 4x minus 11. That's the first thing. Please make sure that you are following. I'm completing the square again for you guys. Negative 1 outside. Now, we say x squared let me simply say minus 4x. Let's leave some space there. Minus 11, and then leave some space there and close the bracket. That's just the equation as it is. I didn't do anything. I just left spaces in between because these spaces are going to come in handy for me. Now, let's finally complete the square. What does the rule say? It says you have to take the coefficient of what? Of x, and you need to divide it by 2. What's the coefficient of x? It's 4. So what do? You take that coefficient, you divide it by 2, and you square everything, right? You add it. Now, because you've added something, you've now changed the value of the equation. But if you want to go back to where you started, you have to subtract what you've added. Because if you think about it, this cancels that. One is positive, the other one is negative. Okay? Now, I'm going to say this is what? -1, open bracket again. This is going to be what? Take the square root of x squared. That gives you what? X. Now you have negative and positive. This is going to be negative. Now, 4 divided by 2 gives you how much? It's just 2, right? 2 squared is 4, but the square root of that is just 2. You need to put a squared there. Minus 11 minus 4 gives you what? Gives you minus 15. Multiply the 1 in. Negative into x minus 2 squared plus 15. And this is what we're looking for when you complete the square. Okay, somebody's asking, is it not -4/2 all squared? Yes, you're absolutely correct. I omitted it here only because it's squared, but it definitely is -2. So that we don't make any mistakes, let's all include that negative. This time around, it worked out only because the negative is also squared. If you include negatives, you'll see that the answer is still the same. Nothing changes. But thank you so much for that, Rutulwe. It must be -4/2 squared, okay? Now you guys are comfortable with the two options. You either complete the square or you differentiate. Okay? Moving on. We're still doing analysis of functions. Now we're looking at intercepts between functions, right? So what's that? Where the two graphs or more touch each other. Usually they will give you two graphs that touch each other. So we want to see where they touch each other. And how do we find that? We can find the point of intersection by what? By equating the two graphs to each other. Okay? That's when we say f of x is equal to g of x. Then they're saying to find the corresponding y coordinate, substitute the value of x, substitute it back into either f of x or g of x. Let's just forget about that. This is the typo. The value of x back into either f of x or g of x. Okay. Now we want to find these 2 points. Let's say this is A. No, I can't use A and B. I'll say maybe P and Q. This is P and this is Q, right? Now, how do we find that? Equate the two graphs to each other and then try to find these. I'm going to give you guys 1 minute and 20 seconds to try and find those. Because this one is very easy. You're not completing the square. You're just equating them. This is the first step. F of x is equal to g of x. Okay? Please try to do that quickly. And then we're going to mark shortly. If you're struggling, do not worry. I'm still going to show you guys how to go about it. Okay, once you have an answer for me, you're more than welcome to post it in the Q&A or the chat. You're left with 30 seconds before I show you guys how to go about it. Okay, thank you so much for the answers that are coming through. I'm getting different answers. I'm just acknowledging the answers that are coming through. Okay, perfect. Let's quickly look at these. So equating them, we're just going to say minus x squared plus 6x plus 12 is equal to what? 2x plus 1. Okay, then I'm going to say 0 is equal to, so I want to take f of x way to the right hand side. X squared minus 6x minus 12 plus 2x plus 1. 0 is equal to minus 4x minus 11. Are we together there? Now, we won't be able to factorize that without the use of the quadratic formula. You're going to use the quadratic formula. It's given on the formula sheet. You do not have to memorize it. X equals to negative b plus or minus the square root of b squared minus 4ac all over 2a. Then you're going to get x is equal to what? Either negative 1,87 or x is equal to what? 5,87. Now we know that this is what? This is x of p. What do we want? We want to find y of p. This is x of what? This is x of q. We also want to find y of q. What are we going to do? We're going to substitute it. Where? I always take the easy way out. The straight line. Although the quadratic is also going to work, the straight line is the simplest for me. So I'm going to simply say that this is going to be 2 into negative 1,87 plus 1. On the other side, it's going to be 2 into 5,87 plus 1. And then you find the corresponding values for P and Q. I'm hoping that is clear for everyone. Perfect. I'm getting a thumbs up, which means that everyone is following. This is quite easy. Please do not get this one wrong. Make sure that you attempt this question. Okay, don't leave it out. Great stuff. Okay. Now, you can take a screenshot quickly before we move on. This was intersecting functions, a point of intersection of two graphs. Okay, perfect. Let's move on. Here's another one that I'm going to let you guys attempt. It's quite easy. I just did an example. Then I need you guys to find what this point here. I'll say this is S, and then I'll call this T. I want you guys to try and find the coordinates of S and T. Try to follow the steps that we just did. Right? And don't worry if you don't get it right. I'm still going to show you guys how to go about it, but please do attempt it quickly. I'll give you guys 1 minute and 30 seconds to quickly look at it before we move on to other questions. And remember to share the information, guys. If you're a part of a school WhatsApp group and you know your classmates can benefit from these sessions, you're more than welcome to share the link with them, let them attend these sessions so that we all benefit from these sessions, okay? Remember to like, follow, and subscribe to our various channels. Okay, once you have answers, you're more than welcome to start posting them in the Q&A or in the chat. Thank you so much to the guys who are also joining us live from TikTok. If you'd like to partake in these sessions and ask questions so that it's nice and interactive, the link will be shared with you guys as well. Do check the comment section so that you can just register and join us on Zoom so you can ask the questions that you have for me. While you're on TikTok, it's free to like our videos, to subscribe, and to follow us. Okay. I hope we are not struggling with this one. I'm not seeing any answers in the chat. And for the sake of time, I'm going to attempt it. All right. What do we do? What's the first thing? We equate them to each other. Okay. So f of x has to be equal to g of x. Right. Okay. I'm getting some answers in the chat. Thank you so much, Lerato and Azaria. Thank you. 1 over x, then plus 3. I nearly said 1 over 3. That is equal to 2x plus 1. Now, I dislike working with fractions. What I'm going to do is I'm going to try to get rid of the fraction by multiplying every single thing by x. Multiply by x, multiply by x, multiply by x, multiply by x. Then I'm going to have what? 1 plus 3x is equal to 2x squared plus what? Plus x. Make sure that you're with me every step of the way. Then 0 is equal to 2x squared minus 2x minus 1. You're more than welcome to stop me if I'm making mistakes, but I'm going to try to pay attention. Then this can be x, but because there's a 1 here, I don't want to divide by 2. Then I'm going to be having a fraction. So I might as well just leave it as right. If you're not too comfortable with factorizing this, you must use what? The quadratic formula. And I think for this one, you have to use the quadratic formula. I don't think we can factorize it. It won't work out. And I think the first x is 1,37, or x is equal to what? Negative 0,37. And then what do? We have our two answers. So this is x of t, and this is x of s. So to find y of t, we're simply going to use the straight line. The straight line to me is the easiest. So this is going to be 2 into 1,37 plus 1. And then y of s is 2 into negative 0,37 plus 1. Okay, here's a great question. Why are we multiplying everything by x? The reason is we want to try and get rid of this fraction, because now otherwise we're dealing with a hyperbola and a straight line, and we don't know how to deal with that. The only way is to get rid of that hyperbola by making a new function, which is a quadratic. All we're trying to do is get rid of the fraction, not function, but fraction. I'm hoping it's clear to you guys. Now you're not going to get it wrong again. Okay, if you want to take a screenshot, please do so quickly. Before we move on. Emitle, this might not be the only way, but I think this is the easiest way to remove that fraction. If you find a method that's a little bit easier than this one, you're more than welcome to use it. I usually like explaining what I think are the easiest methods. Okay, perfect. Moving on. Now I need your guys' undivided attention. Okay? These are interval type questions. They like these questions a lot. I guarantee it in your prelims and in your final exams, you will definitely get a paper. You will definitely get this question in your paper. Okay. All right. Naledi has their hand raised. I'm going to ask my colleague to help Naledi unmute themselves. Naledi, you can unmute and ask your question.
Hello, sir.
Yes, Naledi?
I wanted to ask, why were we substituting the answers that we got from the quadratic equation into the 2 plus 1? Like, why were you using that specifically?
Okay, that's a good question. Now, remember what I said? That I like using the easiest one, and I think the straight line is the easiest. But if you didn't use the straight line and you use the hyperbola, you're definitely going to get the same answer. It's just that the straight line looks very neat to me. I just need to substitute there. I don't like working with fractions. Some people might prefer that fraction. That's perfectly fine. It really, really is up to you.
Okay.
Perfect.
Thank you.
You're welcome. Okay, so talking about the interval type questions, right? They will ask you, where is f of x multiplied by g of x greater than 0, or where are they less than 0? Okay, so let's check what they're saying there. To determine where the product, right, or quotient or division of two functions is positive or negative, right? Basic rules of multiplication are considered, right? Please forget everything that you're doing now and pay attention to what I'm saying. This question here. What are they trying to say with these symbols? There's a lot happening there. All they're saying is that f of x multiplies. So the dot implies what? Multiplication. So when you multiply the first function with the second function, you must have what? Greater than 0. What does it mean? It means that you are having a positive. Greater than 0 means positive, remember? Now, how can you get a positive when you're multiplying two things to each other? Here's the first option. They both have to be what? Positive, because positive times positive will give you positive. Sorry about that. Or they have to be what? Negative times negative. Because negative times negative gives you positive. Those are the only options that work for this part. I repeat, we're saying f of x, the first function, multiplied by the second function. That product must give you a positive answer. The only way you get a positive answer is if the first function is positive and also the second function is positive. Or if the first function is negative and the second function is also negative. The signs cannot alternate. They have to be the same for you to get greater or equal to 0. Perfect. I'm getting claps in the heart and thumbs up. So I guess you guys are all with me. Okay, there's a question. Let's see who we can help. Okay, maybe the hands are now down. Maybe it was a mistake. Okay. We are going to deal with those questions. So just let me explain for now. Now, the product is positive, thus both should either be positive or both negative. That's what I was saying to you guys, that the signs need to be exactly the same. Positive times positive is positive, negative times negative is negative. Now the sign changes. Check here. Now it's something different. The sign changes. The crocodile mouth is now eating the 0. It's less than. So if it's less than, what do we know? We want what? We want a negative. We want the sign to be negative. How can we get a negative? We can get a negative if the first graph is positive and then the second graph is negative. Or if the first graph is negative and then the second graph is positive, not times, but positive. Right? So the signs have to be opposite. They have to alternate, positive, negative, or negative and positive. That's the only way you can get 0. All right, now let's go back. What do we even mean by these signs? So what we mean when we say a graph is positive or it's negative, we are simply saying, where is this graph above the x-axis or where is it below the x-axis? Okay, I know that doesn't make sense until maybe I draw something to show you guys. We have a straight line, so this is the point -2, and then this is the point +2. So we have a straight line that is passing through these 2 points like that. Where is this graph negative? This graph is negative. Where x is what? Is less than -2. That's where the graph is negative. It's under the what? The x-axis. Cabello, be very careful there that it's -2. Okay, not just the 2. Now, where is it positive? That's where it's above the x-axis. And that's where x is what? Is greater than -2. I need you to understand that because we have to apply this when we deal with those functions. If you understand this, you'll see that the questions are a walk in the park for you guys. Moving on. Now here's a question. For which values of x is what? Is f of x multiplied by g of x less than or equal to 0. Okay, so there's a question. Let me just go back before I attempt a new one. So somebody's asking why a -2? Because we're looking for the value of x, the values of x for which the graph is positive and negative. And the x value is this side. Remember, here we have 0. These are all positive and these ones are all negative. Here's the -2. Sorry, it's not very clear, but there's the negative. So at this point, this is negative, negative, because it's under negative. But here, positive, positive, positive. Okay. If you want to take a screenshot, you can do that quickly, but the notes will be made available to you guys. Okay. So let's actually do the problem now. For which values of x is f of x multiplied by g of x less than or equal to 0? Right. For us to have less than 0, what do we need? We need positive and what? And negative. That's what I was explaining here. Positive and negative. Right? The order doesn't matter. If you said negative, then followed by positive, that's perfectly fine. Right? Now, we want a region where one of the graphs is on top of the x-axis, whilst the other one is under the x-axis. So check something here. Let's look at the straight line. Starting from here, can you guys see where I am? Starting on the edge here. That's where we're going to start. This straight line, is it positive or is it negative? Starting here. It's negative because it's under the x-axis. Negative, negative. Now there it's 0. Now it's positive because it's on top. Please make sure that you understand that part. The difference between positive and negative, it's just when it's under the x-axis and when it's on top of the x-axis. Now let's look at the parabola. Where is it negative? Negative, negative, negative. Where is it positive? There. Now it's negative again because it's under. Okay. Now I'm going to break this down for myself. Let's look at, in between here. Can you see that both graphs are negative? Because they're both negative, that doesn't work. Okay, moving on. I'm going to break it down to this part here. Can you see that both of them are positive? Positive, positive. It doesn't work. Now from 6, this is negative. It's under the x-axis. But the straight line, remember it's a straight line. It will not come back. It will keep going up. It will keep going in that direction. And if it keeps going in that direction, what's going to happen? It's going to keep becoming positive. The gradient doesn't change of the straight line. Now check this region. From where? From positive 6 going way to the right. This parabola is not going to come back up. Here's a positive and that's a negative. Those are the alternate signs that we're looking for. Then what can we say? X must be what? Must be greater or what? Or equal to 6. Right? We're not done. We're not done. Pakiso saw it. Thank you so much for noting that down, Pakiso. At this point here, they're both 0. So x is greater or equal to 6, or x is equal to 0. Because at this point, when they're both 0, What do we get? We get less than or equal to 0. Remember the question says less than or equal. So if it's equal to 0, that's perfect. Both of them are equal to 0 at the origin. They both cross through the origin. Both of them. So that is x is equal to 0. That's a point. And then greater than 6. Why are we including the 6? Because they gave us an inclusion there as well. So they said less than with an inclusion. This means inclusion. Include. If it was just less than, we wouldn't include the 6. We just say x is greater than 6. I'm hoping that's clear. So the correct answers, x is greater or equal to 6, or x is equal to 0. Great stuff. Right. We're going to just leave this one out because we are not left with too much time. I want us to quickly address some functions so that we can look at some past paper questions as well. All right. But I've given you guys a lot of information. It will be easy for you guys to then tackle these questions. Okay, so looking at inverse functions, I see some questions in the chat. I'm just going to try and blitz through inverses, but I need you guys to understand it. If there's time, I will come back and address some of these questions that you guys have for me. An inverse function does the reverse of its original function. We compute the inverse function by interchanging the output y and the input x variables, right? So we swap the x and the y. Given a function f of x, we determine its inverse f dash 1 or f negative 1 of x with these generic steps, right? So they gave you the steps on how to determine an inverse. So all you do first is you what? Number one, you swap the x and the y, the positions of x and y. Then you make y the subject of the formula or equation, and then you express the new equation in function notation. What does the last one mean? It simply means, right, f dash 1 of x. This means what? This means inverse. And those are the steps that you guys need to follow to find inverse functions. Okay, and this was a very easy one there where we had y is equal to, I'm going to make my own 2x, then I'll say minus 3. What we want to do is we want to try and find the inverse of, let me just say this is f of x. Right, but remember that f of x is y, so y is equal to 2x minus 3. So if you want to take a screenshot, please do so quickly so I can move it out of the way. Okay, perfect. Now, let's follow the steps. Swap x and y. X is equal to 2y minus 3. That's the first step. Now, next step. Make y the subject of the equation. So 2y is equal to what? Is equal to x plus 3. So all I did is I took the 3 over to the other side and then it became positive. We haven't made y the subject until we get rid of the 2 in front. So y is equal to half of x plus 3 over 2. Right? That's the second step done. Express it in function notation. And that's how you invert it. That's how you find the inverse. Okay. Now, what exactly is an inverse function? So an inverse function is what we get when we reflect the original function about the what? About the line y is equal to x. So if you put a mirror here, let me change the color. Let's use this one. If we put a mirror there about the y is equal to x line, the function is going to reflect, and then it's now going to be like that. That's what we are seeing here. And that is an inverse. because now the y values have become the x values and vice versa. The x values have now become the y values. Okay, and they're simply saying the graphical result of an inverse function is a reflection of the original curve about the y is equal to x line. Now they're saying the range of the function becomes the domain of the inverse relation and vice versa. Okay, so this one, remember, it's not a function because of that. The vertical line test, we're touching the graph twice. Okay, now let's explain these. Domain and range. So I used to confuse the two. And then this is how I decided to write range. Right? I write it with a y value. I write it how I say it, range. Okay, now I know I'm dealing with the y values. And obviously, if range deals with the y values, what am I left with? I'm left with domain. I've already used up the y values. Which other values are left? The x values. Now, if we have a function, so let's just say that this is f of x is equal to x squared minus 2. So this is 0 and minus 2. What is the range of this graph? The range, we know range deals with the y value. So y is what? Is greater or equal to -2. That is the range of that graph. What is the domain of this? The domain is x is an element of what? Of real numbers. Why is it x an element of real numbers? It's because as much as it's going up, it's also it's opening wide. As much as it's going up there, it's going to the right. So to the right, it's pointing at positive infinity. To the left, it's pointing at negative infinity. Now, y cannot be an element of real numbers because if you're saying it's an element of real numbers, here's a real number that I'm going to give you. -10. -10 is a real number. What is the value of that graph at -10? -10 is going to be somewhere here. The graph doesn't exist at -10, but it starts existing from -2 going up. For anything smaller than -2, the graph doesn't exist. So when they say range, they're simply saying the y values where the graph exists. Domain, the x values where the graph exists. Okay, so here they're saying negative infinity to infinity, perfect. So you can say x is an element from soft bracket, negative infinity all the way to positive infinity, soft bracket. You never ever write hard brackets around infinity. Okay. Otherwise, it means that you have found what the values of infinity are. We never ever write that. All right, let's move on. Now, the one that gets a lot of students is the log one. Okay, so when you are inverting an exponential, right? Let's see how we can deal with that. It shouldn't be a problem at all. The problem is the algebra. Okay, make sure that you spend a lot of time looking at algebra. Now that the schools are closed, make sure that you do a lot of revision there. So consider this graph here, or this function y is equal to b to the power of x. And we want you to find the inverse of this. What's the first thing that we need to do? The first thing that you need to do when you find inverses is to swap x and y. Check what I'm going to do. X is equal to b to the y. That's the first thing. Now, the next thing is you need to log both sides. So remember, whatever we do on the left, we need to do it on the right. Check what I'm going to do. There are shortcuts. If you're comfortable with the shortcut, you can carry on using the shortcut method. So I'm going to say log on the left-hand side and then log on the right-hand side. That's the only thing that I did. I introduced this. Whatever I did on the left, I needed to do on the right. That's all. Hope everyone is with me there. Now, the rule says if you have a log and a power, it must come in front. The power needs to drop in front. So on the left-hand side, we still have that. On the right, the power needs to drop and come in front. I hope everyone is still with me. Then, by dividing both sides by log of b, this cancels that. But whatever we did on the left, we also need to do on the right. What? Log. Laws say if you have a log divided by another log, the bottom one becomes the base. So log base b with an x. But there is a shortcut. Hope everyone is with me there. And that's how you basically do it. You just follow the steps. Even if they try to complicate the equation, you must just follow these steps. Okay. Now, let's look at this question from a past paper. I'm getting a thumbs up. I guess everyone is with me. Thank you so much for responding. The very first question there says, show that the equation of g is g of x is equal to x squared minus 2x minus 3. The equation of g. G is the quadratic. What is it that we have? We have a turning point and we have another point. We know that this point is what? It's 3 and 0. The y value is 0 because this is the x-intercept. We don't have anything else. So automatically, because we have a turning point, what are we going to use? We're going to use the turning point method. Okay, a lot of people are asking me what the shortcut method is. So the shortcut method, so after saying x is equal to b to the power of y, all you're going to do is you're going to say b has been the base all along, right? So you're going to say log of the base. What has your base been? It's been b. And then the x and the y swap positions. So you have x there and y on the right-hand side. So what I mean is this. If you had x is equal to 2 to the y, the shortcut simply says, you say log, y is on the left, y is equal to. What has been the base? The base has always been 2. And then that's the x there. And that's the shortcut. Okay, I'm getting a thumbs up, so we can quickly move on. Okay, so as I was saying here that we need to use the turning point. So the turning point will simply be what? The turning point formula, y is equal to a into x minus p all squared plus q. Let's substitute what we have. Y is equal to a into x minus 1 all squared and then minus 4. I just substituted the coordinates of t. What else do I have? We're going to sub in the x-intercept. So 0 is equal to a into 3 minus 1 squared minus 4. Then 0 is equal to a into 2 squared minus 4. So a is equal to positive 1. Now we're winning because we have the a value. So we can say y is equal to 1 into x minus 1 squared minus 4. Then you just have to FOIL it out. Y equals to 1. The 1 outside we don't have to write, but I'm just going to keep it there. The mistake that you can make is bringing this in. Please do not do that. The squared simply means 2 brackets. Y equals to 1 into x squared minus 2x plus 1 minus 4. That's when I FOIL this out. Y equals to x squared minus 4x plus 1 minus 4. This is just x squared minus 4x minus. Sorry, I'm saying 4 and it's a 2. My mistake. My mistake. This is just a 2. I don't know where I'm getting the 4 from because it's multiplied by 1. It's 2x, 2x. It's a silly mistake on my side. And then this is just a minus 3. And as you can see, we have what they requested there. Okay, you can quickly take it down, and that's how you need to do it if you are given a turning point. Okay, now let's quickly move on. Now the next question says, determine the x coordinates of the points of intersection of G and P. All right, I'm going to let you guys do that quickly. So all you're doing is you want to find the x value here and the x value there. Please attempt it quickly. Once you have those x values, you can post them in the chat. Okay, thank you so much, Ndebo. If you have different answers, you're more than welcome to share them. I'll give you 45 more seconds to quickly calculate. Okay. It's 9 over 2 or 2. And those are the answers that I am getting as we are equating half of x to x squared minus 2x minus 3. Then from there, it's just basic mathematics. Why? We dislike working with fractions. So we'll just say x plus 12 is equal to 2x minus 4x minus 6, because you multiplied everything by 2. Right? This is still a squared. All right. And then you simply solve for x. For the sake of time, I'm going to leave that in your guys' capable hands. But the answers are x is equal to -2 or x is equal to 9 over 2, which is 4.5. All right. Now let's move on. Determine the values of x for which g of x is less than or equal to p of x. So what does this mean? Right? You might say we didn't discuss that, but the logic is still the same. What are we trying to do? All we're doing is we are saying, where is g of x under p of x? Where is g of x under p of x? Okay, do not try. I beg you guys, please do not attempt to do it algebraically. Look at the mark allocation. It's 2 marks, so it isn't that difficult. Okay, let's see if I can move it up a little bit so I can see the diagram as well. I'm going to zoom out a little bit. You guys should still be able to see. Okay. We want g of x to be under because the crocodile mouth is eating p of x. P of x is what? Is the straight line. So if we go to the straight line, this is the straight line. There. If I look up there, I'm not seeing anything. If I look down, what am I seeing? I'm seeing g of x. It's g of x under the straight line. In that region, bound by the 2x answers that we just got. Hope you guys are with me there. It's bound by the 2x answers that we just calculated. Okay, now how do we do that? We simply say what? X lies between what? -2, I think that's what we found. And what? And 9/2. Are we all together there? Right? If you want to use something else, a different way to represent it, that's perfectly fine. If you wanted to say x is an element from what? From -2 all the way to 9/2. That's perfectly fine. Okay, cool stuff. Perfect. Now let's quickly move on. We're just going to leave that one out and then do a different question because we just did quadratics, and for the sake of time, we're just quickly going to move on to a hyperbola. Okay, now let's check what's happening here. Write down the equations of the asymptotes of P. The equations of what? Of the asymptote. There we go. People got them quickly. X is equal to -2. That's one of them. And then what is y? Y is equal to -3. 2 marks. Now, write down the domain of P. What do we know about domain? Remember, I said differentiate between domain and range. Range is the one that deals with the y values. Automatically, you're dealing with the x values now. Domain deals with x. So you're going to say that your domain is going to be x is an element of what? Of real numbers, but there's something else. X cannot be equal to what? -2. So x is an element of real numbers, but x is not equal to -2. Because if it's -2, it means now we're dealing with something like this. -2 plus 2. Now it means we're dealing with -4 over 0. And this is undefined. Hope it's clear there. Yeah, there was asking, can I explain why x cannot be equal to -2? I just explained it here because if x is ever equal to -2, we're going to have -2 plus 2 in the denominator. -2 plus 2 gives you 0. -4 divided by 0 gives you undefined. Whenever you divide by 0, you get undefined. Okay, quickly moving on. Now they're saying write down the range of P, the range of this particular graph. Now we're dealing with the y values. If you know the answer, if you think you know the answer, please do type it in the chat quickly, then we can address it. So the range. Yes, y is an element of real numbers, but y cannot be equal to -3. Why? That is the asymptote. It never ever touches the asymptote. Okay, so we're just going to skip the rest and quickly blitz through the exponential. Okay, just so you guys know how to deal with this as well. Okay, so if you want to take a screenshot, here you go. But these notes will be made available to you guys. Okay, quickly take a screenshot, then we move on. Okay, so here's a function. The following sketch shows the graph of f of x is equal to -1/2 raised to the power of x minus 1 plus 4, and another function g of x is equal to a multiplied by 3 to the power of x plus q. Right, now determine the coordinates of a and b, show all calculations. Okay, that shouldn't be difficult at all to find the coordinates of a and b. So we're looking for this and that. Immediately seeing that this is the y int and this is the x int. All right. Cool. Now, the first thing that I want to do is for the y-intercept, I know that x is equal to 0. So y int x is equal to 0. Then I'm going to say, which graph do I have? I have f of x, right? I don't want to use this one because I have a lot of unknowns. So I'll say y is equal to -1/2, 0 minus 1 plus 4. And this is going to be calculator work. So that's going to be negative. So this is simply going to be -2 plus 4. So y is equal to +2, which means that a has coordinates what? 0 and +2. Now for b, that's the x-intercept. So we'll say x int y is equal to 0. Then we know 0 is equal to negative is outside, the half, x minus 1, and then plus 4. Then I'm going to take this to the right-hand side. It's negative, so it's going to become positive. X minus 1 is equal to +4. Right. Now, a half is the same as 2 to the -1. You must remember that. If a half is 2 to the power of 1, all I'm going to do is this. I'm going to simply say that this is 2 to the -x plus 1. This is equal to, I want the bases to become the same. So 4 is the same as 2 to the power of 2. Now, when bases are the same, we consider the exponent. So -x is equal to 2 minus 1. So x is simply what? -1. which means that B has what? B has coordinates -1 and 0. Okay, quickly doing 8.1.2 and then we end there. We know that we're looking for A and Q. So we can start with Q, right? Q is simply how much? Q is equal to 4. We got it from f of x. They have the same asymptote. Okay, if Q is 4, then we can simply say y is equal to A times 3 to the power of x plus 4. And then we can substitute which point? A. So sub A, which has coordinates 0 and 2. So 2 is equal to A times 3 to the power of 0 plus 4. And then we can easily find A because A is going to be -2. And just like that, we have determined the values of A and Q. All right, guys, the time is now 2 minutes after 5 o'clock. I know we did not get to cover as many questions as I had prepared for us, but I made sure that the explanation is thorough. So when you guys look at these notes, please do attempt the questions that I had prepared for us. Right, just so you can track your progress and also look at some past paper questions. Okay, so we are going to end here for today.